Hello guys, and welcome to this new tutorial. We will tackle the Vellum topic today a little bit, especially for beginners, so simple simulation, play with forces, stuff like that. If you want the newest information, go to my Instagram and I will post there, in my stories, new updates. The new Patreon exclusive arrived. This is a tutorial about creating, a flower, a little plant, and so go on my website. Instagram is right above here, so you will get all the newest updates. Okay, I will close that here, and we are in a fresh Houdini scene, and for all beginners here we will start with a simple geometry container. So hit right click on the network view, or let me just get, I think build is the standard configuration. So what I usually do is to disclick the parameters, the take list, and the performance monitor, and I got one big window for my network view or my node view, and I then toggle P on the keyboard, and you can see that the show parameter dialog is enabled. And when I place down a node now, I will see the parameters and all the configuration stuff on the right hand corner here. And I find that pretty good, because you got a lot of space for your nodes, especially when you deal with big node trees. Okay, cool. And you can really simple assess your geometry spreadsheet here. So that's done for now, and I think let's get started with the simple Vellum topic. So go on your network view here, and we will place down a geometry container. Make a right click or press tab on your keyboard and type geo for geometry and place it down. We will call this GeoVellum, because we will work with Vellum, and I will make it round and black. And then we need to dive inside into this container to build up our little simulation. You can dive inside with double click or with the I key, and you can dive up with U on your keyboard, or you can dive back with this arrows here, or you can dive inside, or I think it's Alt and left arrow and right arrow. Okay, dive inside, and we want to place down a simple fabric geometry in the first instance, and we will use a simple grid. So place down a grid here, and we then can resize that to 1 by 1. When you want the size linked, so the coordinates linked on the size here, you can just press right click, copy parameter, and then on the other channel paste relative reference, and now you can see channel size, it's linked. So that's the cool thing, it's now linked when you play with the parameters, so you can always link your parameters. I will choose here a size of 1.5 for now, And after that I will make a remesh because I want to triangulate my mesh here a little bit. And the target size is for the initial size of the elements, so in this case triangles, and a larger target size will give you larger triangulation, and a smaller target size will give you, of course, smaller triangulation. You can also play with these parameters, with the iteration parameter, to get a better meshing, and you can play, of course, with this moving here. There's also, I think, an adaptive edge length, so you can play around with that too. That's fully up to you. I will choose the uniform for now, and after that we will place down a null. So null is like a placeholder, and I think a null is always pretty good to stay organized in your network. We will call this out fabric, and this is our out fabric, but we also need a collision, and I will use a sphere for that. Let's place down a sphere, but we can't see the sphere. We need to place our display flag on here. So display flag with R key on your keyboard, or you can toggle it manually with your mouse, left mouse button, or you can, for example, press the template button, and now you will get a templated sphere here. I will choose a polygon, and I will bump up the resolution a little bit, and I will decrease the uniform scale. So I will choose 0.25 for example, and I will place down a transform node. So again, press tab. Another tip is, when you place down a node and you want it to get directly connected or instantly connected, you type transform, select your node, and then press Shift Enter on your keyboard, and the node will get directly connected. Okay, we connected our transform node, and now let's hit the template on the fabric. So here, template, and now we can press Enter in our viewport, or we can press this little the handle, and we can now drag our sphere under our piece of fabric, and with Alt and left mouse button drag we can create a new node, and I will call this out call for collision object. And now we've got our sphere and our fabric piece here. Cool. Now we need to start the simulation, and I think that's a cool topic for beginners to get inside simple simulation with Vellum or particles, and we will do that now. So we will type down Vellum and VCC, and immediately the Vellum configure cloth will pop up, and we will connect that into the left input. But we also need a Vellum solver. Type VS and get the Vellum solver here, and connect the parameters, the lines here. And now when we press play, the fabric will just fall down and fully ignore our collision object, because we need to import our collision or bind our collision object to the Vellum solver, and we can do that like so. Just connect the out collision on the input number 3 here, and you can see your collision object as a reference of object in this blue highlighted wireframe shading. And when we press now play, you can see our cloth will not ignore the collision object and will get affected. Of course, what we can do now, we can bump up our size here, we can get a little bit higher with the resolution. Oh, there's an error. Let's get the patch, the planar patch here. I think that is a little bit better. And we can link our size here also. 2.5, whoops. 2.5, not comma. Delete the channels. And the edge length is basically the same as the target sizing here. And now that will work better. So we've got now a piece of cloth that will fall down. So we can delete that for now here. The cool thing is we've got one force, and this is gravity. So the gravity will pull our piece of cloth or piece of fabric downwards. But I want to introduce maybe a second force. And we can go on the Forces tab, and there's, for example, wind force. And now I can type maybe 2. And now you can already see we've got a little bit of wind here going on. Of course, you can bump that up to maybe 5, and you've got a little wind force. And with a higher force, I think the piece will get slowly dragged over the sphere. So this will take a while. And eventually will eventually fall over or down, because the wind force is so strong that the fabric will get pulled over the sphere. That's another thing you can experiment with the wind force, but there's another cool wind force. But first of all, I will disable the gravity, and I will disconnect the line here from the collision object, and I will dive inside the Vellum solver, and you already can read a simple little message here. Wire pop forces into force output, so that node, to apply per point forces. And per point forces are pop forces, and for example we can use the pop wind. Pop wind, pipe it in here, play, nothing will happen, because we need to get a wind velocity. So this is basically the same thing as the top configuration or parameters. But the cool thing is we can introduce an amplitude. When we type now an amplitude of 0.5, you can already see we've got a little bit of movement here. And that's like a pretty cool organic movement. And when you introduce now a second force, For example, the pop axis force. This is a force that will spin around given a radius and height. Let's go to speed, orbit speed 5, and I will decrease the radius a little bit. And when we play now the simulation and view it from the top, you can already see a small rotation here will happen. But let's increase the radius again a little bit. So now you can see it much better. And now you can experiment with different forces. And I think that's pretty powerful. Another thing, what you can do, get a planar patch, get a copy and transform. And now we will copy our planar patch 3 times. Go to the handle tool and drag it downwards. And you can see we've got now 3 pieces of cloth here. Well, let me just check something. Yeah, okay. 3 pieces of cloth. Now we can wire that into here, and on the Vellum server on standard configuration is self collision on, and now you can let them self collide over a period of time. Let's just dive inside the Vellum server back and get the wind velocity in the up direction to 1, and our collision object above our fabric pieces here, and then we will start the simulation again. And now you can see they will get slowly affected. Let's disable the axis force for now. Or I think there's still whoops, that was the one the wrong direction, XYZ. The middle one is the up direction. Yeah, now we can also introduce back our pop axis force. And now you can see the cloth will small mistake, will collide with the sphere, and the different pieces of cloth will collide with each other. So a good example is now here. That one here, you can see they will collide each other. And let's increase our total number here to 7. So we've got now 7 pieces of cloth, but I want to decrease the distance between each other, something like that. And I will press simulate again. Or what we also can do, let's do another thing. Let's pipe up the uniform scale a little bit to 0.01. So with each copy, the uniform scale will increase by times 1.1. And now let's play it here and let's see what will happen. So you can see the first pieces will collide, and now the final piece will collide too. And you will get a really cool first organic simulation, especially from the top, like a abstract blooming flower, stuff like that. So when you then play it in reverse, you will get, yeah, another kind of perspective. So always try animation or simulation in the forward direction, and after that maybe in the backward direction. And now you can see we've got a pretty cool, it's played in real time, we've got a pretty cool simulation here. And of course now, just for example, you can place your camera here in this really, yeah, like complex vellum field, and you then can zoom out with the camera and you can open it up, for example, and the sphere will be the center of something, or it will be a product, something like that. And for example, what you can see now, you can see some intersection will happen here, I think. I can't see intersection currently, but they will be there at some point. And then you can pipe up the substeps and, for example, the constraint iteration and the collision passes, so play with that too. And after your simulation, you can place down a Vellum post-process, and with the Vellum post-process you can introduce a little bit of blur here, and the important thing is you can subdivide it, so you get a little bit more geometry detail, and you can extrude it. And I think the extrude option is pretty important, because a cloth always got a specific thickness, and you can then introduce a little bit of thickness here. And after that, for example, you can subdivide it once more to get a little bit of round corners and another layer of thickness. Cool. That looks nice. And especially with the opening and with the closing of the cloth sim, I think that's pretty cool and something to experiment with. Let's have a look at the time. Okay, we can render that, of course, and let's introduce a little bit of blur. Okay, we can delete the whole attributes for the render part. So I will introduce a little bit of more blur here, and I will delete the subdivide for now, because I think that's a pretty okay resolution. And now we can place down a null, so stay organized even if the finish is near, and we will call that out final, maybe out final underscore 001 wxd, something like that. And we'll place down a material RS matte, and the RS matte is for redshift, so we can link our material. I will use a redshift light dome. I will use a light dome here. Cool. Let's make it yellow because it's light. RS dome 001. We will need a camera, so type camera, place down a camera. I will get into the camera deeper a little bit later. Place down a material network. This will be our basically shader network. RS mat for material, and an ROP network. This will be our rendering network. RS out. I will place down a Redshift custom in here and call it RS out 001 or 01. Our camera is already linked. I will introduce global illumination and automatic sampling and optics acceleration for RTX cards. Let's dive up one level. Now to the camera part. When you are on this little window here, no cam, or let's just rename this camera 001, or let's call it main 85mm 001. When you like to move the camera, you can of course use your handles here and move it like this, but I think always a good thing is to move your camera in the camera view. So go here, camera main, and now you are in the camera view. Important step, lock the camera, and now you can freely move around in your camera. I will get a longer focal length for a little bit more compressed look, but of course that's fully up to you. And a little bit more resolution. Redshift camera, I will enable depth of field here, copy parameter, and paste relative reference. You'll see radius down to 0.1, and a bokeh image. I did a tutorial on bokeh images, so you can have a look on that. It's my latest video on YouTube. I will use a bokeh image, and now we can press render. So render view. Oh, we didn't link our materials. Okay, we will link the material later. Let's get a Rec 709 here, and that should be fine for now. We will link our materials now. So we will dive inside our RS mat or our material network. Place down an RS material builder, RS mats Vellum. So Redshift material Vellum, we will dive inside, and we got already a basic material linked here. But now we need to link our material with our geometry here. So we will dive inside here, select our RS mat, and you can do it in several ways. So you can open floating operator chooser. So you get this little window. You will go to the RS mat and to the RS mat Vellum, and now they are linked. Or there's another way. You can press Shift W, the tree viewer will get enabled, and then you can just drag and drop your material in there. Cool. Now we press the render button, and I will get one more stop here of light. And now you can play, for example, with the presets of Redshift. So you know I love copper. You can play with copper around, or another kind of material. Let's make a little bit more advanced material, for example with a little bit of noise. Place down RS material, then place down RS maxon noise, and we'll link for the view. We will link the maxon noise directly to the surface, and you can already see the noise appearing on the surface here. We will pipe that into the surface. We did that, and for example we can use, where is this one, SEMA. So you will get this really swirly organic pattern effect. That's pretty okay. And we can place down a ramp, and now we can remap our color values here. For example, from yellow to black. Of course, we can adjust them a little bit and then pipe that into diffuse color, and you will get something like this. So I think that will already do the job. Don't forget to set it on, I think there's UV vertex attribute, and you will need a rest attribute. So just try out object for now. Of course, this will not stay the same, but for the first little R&D, I think that's okay. And yeah, now you can fully experiment with the materials. You can, for example, choose a preset here, the infrared, and let's use another kind of noise here. Where is the Luca? And you will get something like that. So fully currently doesn't really look like cloth. So for cloth you can use of course you can use UVs paired with bump maps and cloth textures. We can do that. So if you want a simple UV for just a simple patch here, you can just type UV project, and you've got your really simple UV. There's also, I think, the auto UV, Labs auto UV will do the, I think will do the same job. Yeah, so just try out the auto UV, and of course for that kind of structure here, or that kind of polygon, the UV will get pretty simple, and the UV will get automatically copied onto the other instances of geometry. And yes, now you can experiment with your own little setup, and please try out other forces, stuff like that. And yeah, I think that's it for that kind of tutorial. I hope you liked it, and I will see you in the next one. I will see you in courses. The link will be down in the description, on Patreon, on Instagram. Hit me up, ask questions if you got some, and stay safe, make R&D, and I will see you in the next one.